All right, guys. So, first things first. So, if you're wondering, I guess, how to figure out the kV of a motor, I'm obviously using a lathe because that's what I've got. If you've got a cordless drill or a corded drill, you're going to need a tachometer. You're going to have to add something to this. You're going to need to find a way to record the RPM of your drill. But you can pretend this chuck is basically a drill for this project. If that's all you have is a drill, this will work. So to find kV of a motor, you need a voltmeter, you need something to spin your motor, and that's basically and a calculator. So I don't know if I wrote this down. kV, and you can pause this here. To find kV, you're going to take the voltage, multiply it by this, divide it by the RPM, and you'll get kV. All right? So I'm going to show you basically that now. So what I've got is actually two motors. I've been out of the hobby for a little while, and I'm kind of trying to get back into it. And I've got some of these Fiu, I don't know what this is. I got it. It came, a friend of mine was kind of getting out of it. He was moving, actually, and he just handed me a bunch of stuff, and he's like, hey, I don't want to move with all this. You can have it. So he gave me a drone with 4 of these, and then I've got, if you've been in the hobby, this is a Microdan, and I have no idea what kV it is. Microdan are great motors. They don't make them like this anymore. I'm pretty sure Microdan may still make these. I don't know. But I don't know what kV this thing is. I don't have any documentation. I've had it for a long time. So I want to find out the kV of this. So I'm going to start with, this is an Emax. I guess I could rotate here. Let's do it like that. This is an Emax 2812. These are listed at 1534 kV. That's the official number of the kV on this motor. So we'll start with a known quantity and see how close we get. And if it's in the ballpark, then we know that we can at least use that to ballpark an answer. So what I'm going to do is, first and foremost, I'm going to violate some rules of rotating equipment. I'm going to be in here playing around with my hands on this lathe. So be careful, obviously. But sometimes you got to do what you got to do. So what we're going to do is, what you want to do is you want to start something with RPM. You want to be able to turn the motor, and these leads hanging off is enough to prevent the mount from turning. It'll stay stationary. This will turn, and then we're going to take the leads, and we're going to call it 1, 2, 3, or the way you're looking at it, it may be 1, 2, 3, but I'm going to take the voltage off of these two, and then we'll take the voltage off of these two, and then I'm going to take the voltage off of these two. Okay, so I'll get the voltage off all three at a consistent RPM here. I'm going to try and set this for about 500 RPM. We'll get the voltage, and we'll see what we get here. All right, so make sure everything's clear as can be. Let's go. All right, so I'm showing, and you can't see it because it's over here, but my tach says this is 300 RPM. And I'm showing 158.6 millivolts. So that's what? That's 158 volts. So for 1 and 2, I'm going to call this, I'm just making some notes off screen that you can't see. We're going to go 1 and 2 is going to be 0.158. All right, and then I'm just going to switch this right here. Try and keep those from touching. And again, so 1 and 3, 0.158, because we're having to convert millivolts to volts. So 0.158. 1 and 3 is 158. I'm going to remove 1 because I need to get these two. And we're back at 0.158. We'll call that 2 and 3, 0.158. So now what you'd want to do is you want to get the average of these three to get your voltage, your nominal voltage. And it was 158. So then this is what we're going to do here. We're going to use this formula again. Is this in screen? All right, I'm going to shut this off so I don't get my fingers caught up in it. But this is the formula we're going to use. So I'm going to take, normally if I had 3 varying voltages, I would take those, get the average, and use that. But since I don't have it's 158, I'm going to take this 158 and I'm going to multiply it by 1.3433. So let's see here. Again, off screen. I don't know, maybe I can get it a little bit on screen. I'd have to do it upside down. What are we talking? 0.158 times 1.3433. And that's going to give us, this is going to be our calculating number. So we're going to call that, that's going to be 0.2122414. All right, so now what we're going to do is we're going to take that number and we're going to take our RPM, which was 300, divided by 0.2122122 and you could probably abbreviate that number some, but that's in there. And that's going to give us 1413. So 1400 kV-ish. Let's try something. Let's do a magic. Let's try. So I've done this a couple times at 500 RPM, and I got 1450 kV. So let's just bump it up and see if it changes any. All right, we're at roughly 1,000 RPM. We're at 1044. It's a Chinese lathe, so I can't dial it any much better than that. So what do we have? 525. I'm going to do this just so it's easy on me. $526 between 1 and 2. We're going to go 1 and 3. 528. And then we're going to go 2 and 3. $525. We'll shut that down. I'm going to go 0.526 plus 0.528. That was our second number. Our third number was 0.525. Average those. 0.526 plus 0.528 plus 0.525. That's 1.579 divided by 3 to get the average. So we're going to go with 0.526. I'm going to multiply that number. 0.526, 3 repeating. I'm going to multiply that by 1.3433. And that's going to give me 0.70. It's 70 almost repeating. So I'm going to divide my RPM of 1044, I think it was. What did I say? 10. Oh, I just lost my number. Mercy. Okay, let's do it again. 526 plus, I didn't write it down. 528 plus 0.525 equals, divided by 3, that was 526. We're going to multiply that by this 1.3433 equals, that gives us our 0.70, 23, 567. That's that number. And so then we're going to take our 1044 divided by 0.7070232357, and we get 1476. So, you know, I don't know how accurate you want to call. So this is labeled as a 1534 kV motor. And I'm showing anywhere between 1450 and 1476. So I think, you know, for rough numbers, if you're trying to calculate things, that probably works well enough, right? So let's try. I think that's good enough for government work per se. All right, so this is our microdan. We'll see what it is. I think it's an 1800 kV, but I really don't remember. So we'll turn this on. We'll go volts AC. And I'm going to go a higher RPM because that seems to give maybe a more accurate number. So let's go high RPM. All right, so our RPM is roughly 1032 is what it's showing. So we use 1032 as my RPM number. And what is that? 273, so 0.273. That's 1 and 2. So we'll switch here. We'll go 1 and 3. $273. Now we'll go 2 and 3. $272. 0.272. So we'll shut that down. So I'm gonna average those just because I'm not gonna worry about it. They're close enough that I'm gonna call it 273. So we're gonna multiply 273 times 1.3433. Again, this is the formula I'm using. 1.433, and I get 0.3667209. So what I'm going to do is I'm going to take my RPM, which was 1032. RPM, not KV. My RPM was 1032. I'm going to divide that by 0.3667209. And I'm going to get a 2814. So that's a 2800 kV. It's not a 1800 kV like I thought it was. And that kind of makes sense. That's actually, you know what? I think that's supposed to be, I think Microdan called it the 2835. The Poison Arrow, I think. I'd have to Google some of that. But I think this is the Poison 2830. The Poison Arrow is what he called it, the 2835, given a 2814 kV. So that's good enough for me. If you want to watch, I'm going to do one more motor. If you don't want to watch, you can turn it off, and I appreciate you staying this far. But I'm going to get one more motor. This is the Tech. No name, don't know anything about it. I'm thinking about putting this in I'm thinking about giving this to my nephew and letting him put it in a little, a flight test. A tutor or maybe a trainer. He wants to learn to fly, so we're working on a setup for him. That's the whole reason. That and the Microdan are why I'm doing this test. So we're hooked up between, this time we got colors, but I'm gonna still call it 1, 2, and 3. Get out my cheat sheet here a little bit so I kind of scribbled it up. All right, so between 1 and 2, and then we're gonna go between 1 and 3, and then we'll go between 2 and 3. So everything looks clear. Nothing should hit me in the eyes. I do have my squints, my safety squints. So start her up. So this one obviously isn't as, it's not as centered. So I've got some oscillation, but that's not gonna hurt anything. So we're at 1038. RPM. What am I reading here? 827. Between 1 and 2. I don't remember what colors were which. The wiggles got me. Okay, so let's go between blue and black. We're gonna call blue 1, black 2, red 3. So between 1 and 2, I've got it all over the place. Maybe because they're touching. Let's see. Call it 827. I'm good with that. I mean, this isn't rocket. We're not launching rockets. Between 1 and 3. $827. And then let's go between 2 and 3. $833. We'll stop that so I don't lose fingers. All right, so the dangerous part is over. So let's do some math. 0.827 times 2 equals plus 0.833 equals 2487, and we're going to divide that by 3 so we can get a... So we're going to go with our average is 829, which we need to multiply again. We're back to this. Hopefully that's in frame. We're going to do 829 times 1.3433 equals 0.829 times 1.3433. That gives me 1.1135957. We're going to store that into our memory. Store that, and then we're going to take 1038 divided by, okay, I don't know how to work memory on this calculator, so we're going to go 1038 divided by 1.1135957. And that gives us a 932. And that's roughly 950, 932 is where I think this motor is. I've done a little bit of research on RC groups and whatnot. And I think these are supposed to be 950 kV motors, which makes sense because that thing, let's see. These motors showed up swinging a big, a 1045 prop. So low kV makes sense. I'm going to run it on probably like an 8, I don't know, something, not a 10, but probably an 8. So I'm not going to overamp it. Should be fine. So that's it. If you made it this far, I appreciate it. And maybe that'll help you out. All right, then.